Hey guys. Okay, so we're going to go over the guided practice, page 22, 1 through 4. The answers are right there in front of you. Um, I'm going to show you why the answers are what they are. Now, if you got them all right, you don't really have to watch this video. It's up to you if you want to watch it. I might have done things a little differently than you did, so for that reason you might want to watch it, but you don't have to. Just congratulations if you got them right. Now, if you got some wrong, not all of them, but maybe one or two, you can fast forward the video to the part that you need to see and just copy what you need to copy. Now, if you didn't do the homework at all and you're just waiting to copy the work, I appreciate the effort, but I'll let you know in the end, it really isn't that helpful. So go ahead and copy the notes, but then what I suggest is that you go back and do the homework on your own without looking at the work, without looking at the answers. See if you really understand why the answer is what it is, okay? But I'll let you decide. You guys are responsible now. You're sixth graders. You make your choices, okay? All right, so the first one, we have pens to pencils. The first thing you should always do is write what it is you're actually comparing. Okay? And it's pens to pencils. I know I advocate drawing, making drawings and stuff, but if you know what a pencil is and what a pen is, don't worry about that. And plus, the problem has pictures there too. So pens to pencils. This is a part-to-part ratio. Okay, just be aware of that. We're looking at a relationship between pens and pencils. Now, the easiest part, believe it or not, is the counting. 1, 2, 3, 4, 5, 6. And pencils 1, 2, 3, 4, 5, 6, 7, 8. So 6 to 8. All right, and I'm going to write this here. I'm going to explain it just a little differently. 6 to 8. So what's it saying? Basically, we have one big group of 6 and one big group of 8. So the question then is, because you also have to simplify this according to the directions, right? It says write each ratio as a fraction in simplest form. All right. So what it's basically asking is, simplest form, if you remember, basically means, can you make smaller groups out of this? Instead of one big group of 6, if you can imagine one big bag of 6 pens and then 8 pencils, can you break that up into smaller groups? Okay, so start like I said earlier. You have to work with GCF. You're looking for the greatest common factor. Okay, if you don't know the GCF, you can work with common factors that they both have. So just start in order. You already know you can make one big group of 1. What comes after that? Can you make a group of 2 or 2 groups? Can you make 2 groups out of that? And again, whatever you do to one, you have to do the other. Again, we're looking for a relationship, right? Can I break 6 up into 2 groups? 1, 2, 3. Yes, sir. Or ma'am. Okay, it looks like I made 2 groups of 3 and 2 groups of 4, right? So that should make sense. Now let me show you mathematically what's going on with the numbers. Because when you're simplifying, you're actually trying to make the numbers smaller. You're trying to make, smaller groups. Instead of one big group of 6, 2 groups of 3. You know that's smaller, right? Because I'm trying to think if there's any other way I can say it, but really, that's what it is. So we divide by 2, because that's what we did. We're saying, okay, we're going to break up 6 into 2 groups, not groups of 2. Remember, there is a difference between 2 groups and 2 groups of 2. They don't mean the same thing. This would be 2 groups. Groups of 2 would be, and I'll put it here on the side. Groups of 2 looks like this, right? Groups of 2. 2 groups is this. No more, no less. So there is a difference. Be aware of that. And I'll even put little stars here because it's kind of important you know the difference, okay? 6 broken up into 2 groups, you get 3 and 4. And that's the answer, 3/4. But, remember in the beginning I said part to part? There is a pattern for that. And you know what? I'm going to write it in. For every blank, there are blank. All right. For every 3 pens. There are 4 pencils. Remember this pattern for part to part. That'll come up a lot in the quiz. Okay? All right, down to number 2. Same idea. Pennies to dimes. I'm going to write down pennies to dimes. Okay, it's another part to part issue, ratio, excuse me. Part to part. Okay, we're looking at the relationship between pennies and dimes. You look at the drawing and you count the pennies. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 to 9. Okay, so far so good. I think you're with me. So I'm going to write it over here. 3 to 9. We have one, I say big, but really, one group of 3 and then another group of 9. And again, the question is, can I break this up into smaller groups? Instead of one big group of 3 or one big group of 9, can I make smaller groups? Okay, I already know I can make groups of 1. One big group of 1, I should say, right? Well, that came out wrong. Let me say that again. I know I can make one big group. One big group. Can I make 2 groups out of this evenly? That are even, I should say. No. What about 9? No. Okay. Can I break it up into 3 groups? Well, hold on a minute. Hold on a minute. If I take this out and put it up here, that works. That works. All right. Now, let's see what we can do here. We can play with it. Or you know what? We can always just erase it. My hunch, 9, broke it up into 3 groups because I know my times tables. That lets me know I can make groups of 3. Right? Now, guys, for small numbers like this, I do dots because it's easy to draw. But for bigger numbers, you can actually use numbers themselves. And I'll show you later if it comes up. So we have 1 to 3. Right? Look at what just happened. I just want a real quick review. 3 pennies for every 9 dimes. One big group of 3, one big group of 9. I asked myself, can I break this up into 2 groups? It didn't work out. You saw that. Can I break it up into 3 groups? Hey, it does work. I can make even groups, equal groups of 3, right? 3 equal groups. I keep saying of 3 again. Up to a point I want to say, forget what I'm saying. Just look what I'm doing, okay? But 9. One big group? Nope. But I can make 3 groups of 3. Okay? So 1 to 3 divided or broken up into 3 groups. Now, as I'm writing this, I see my mistake already. I wrote the answer when really what I should have written was... Now, guys, I'm a little bit absent-minded. I've been doing this for a long time. In my head, I'm going like 50... I'm going really fast in my head, basically. I need to slow down here. But now it makes sense. 3 ninths. 3 broken up into 3 groups gives you 1 per group. 9 broken up into 3 groups gives you 3 per group. All right. And of course, now you got to write the sentence, the pattern. Now, how should we do this? Because I'm running out of space. I don't want to waste page. Let's try this. For every blank, there are blank. Oh, that looks like it'll fit. Excellent. For every 1 penny, there are 3 dimes. And I believe that's what I told you earlier. So that's why it works. Guys, just as a reminder, this space on the left is for you to ask questions or things that, if something confuses you, this is where you write, hey, what did he mean by that? Or if you see another way of doing it, you want to share it with the class, keep track of it here. Hey, what if I do it this way instead? And then do what you got to do. Right? But on to number 3. Same thing. It's a word problem. Last month, Ed ate 9 apples, 5 bananas, 4 peaches, and 7 oranges. Find the ratio of bananas to the total number of fruit. And then explain its meaning. Okay. There's nothing there to draw. But what I'm going to do instead, I'm going to use the words. When I say there is stuff to draw, but you know what? That's too much. I'm not going to draw 9 apples, 5 bananas, 4 peaches, 7 oranges. But I will write the words and the numbers that go with it. 9 apples, 5 bananas, 4 peaches, 7 oranges. All right. And what are we comparing? What's the ratio we're looking at? We're looking at bananas to total. Uh-oh. Now this is a part to total ratio. Okay? Part to whole, also known as part to whole. It can also be looked at like that, but total, in this case, we have all this fruit. I have a feeling we're going to have to add this fruit a little later. Okay? But anyways, there are 5 bananas. But what's the total amount of fruit we have? Well, this is where you have to add, people. 9 plus 5 is 14. 14 plus 4. You can always add 2 at a time. Or if you're really good, just stack them all up. You can add right here. But just for now, I'm going to do it this way. Just see what's going on. And then 18 plus 7. 25. All right. I have 25 pieces of fruit. Again, if I had this all laid out on a counter or a bench or a table, you'd have 25 pieces of fruit. All right. Just like before. I have a big group of 5, a big group of 25. Can I break this up into smaller groups? Right? Instead of one big group, can I have smaller or more groups with smaller amounts? Right? So, can I break this up into 2 groups? Well, I'll have 3 and 2. That doesn't work. And here, if I did it evenly, I mean, if I split it right down the middle, I'd have 12 and 13. That doesn't work. Again, let me remind you what I'm asking myself. Instead of one big group, can I have more groups to break it up into smaller amounts? What about 3? Well, 1, 2, 3? No, that's not going to work. Nope. Nope, even if I did that, it still doesn't work. 1 plus 2 plus 2? Nope. 8 plus 8 plus 9? No, the groups have to be equal. The groups have to be the same. Yes, I have 3 groups, but you have to break it up evenly. Okay, like if I was breaking up $25 into, let's say, money, it wouldn't be fair if someone got $1 more, right? So I'm not going to do 4 because 4 is an even number. There's no way you're going to break up an odd number into an even number of groups using whole numbers anyways. So I'm going to try 5. Oh, yeah, look at that. 1, 1, 1, 1, 1. If I break up 25 into 5 groups, look what just happened. I have 1 to 5. Okay? Do you see what happened here? You just play with it. Now, of course, if you know your times tables, you probably already saw this. Divided, broken up into... You know what? I'm going to write this down. I keep saying divided by, broken up into... I'm going to highlight... Of course, if I highlight, I have to use it. You know what? I'm just going to put a box around it. Divided by, broken up into... Because really, that's what I'm doing. I'm breaking this one group of 5 into smaller groups. I have more of it, but they're smaller, right? So 5 broken up into, divided into 5 groups. You know what? I like that divided into. Should we erase this? Nah, we'll just leave it there. You get the idea. Divided by 5 groups. Divided by 5 groups. And by the way, when you do the math test, you don't have to put groups. I think if you get it, that's good enough. Right? And of course, it is part to whole, right? Part to total, part to total. You're going to use a different pattern, okay? And this is where we do the whole out of. I mentioned this earlier. Something out of something, noun, is another noun. Let's see if we can get this. All right. 1 out of 5 fruits, right? Fruit is a noun. 1 out of 5 fruits. That's what this is. Again, banana, total. But it doesn't make sense to say 5 total. It makes more sense to say fruits, right? 1 out of 5 fruits is... Now, I should add the word a, banana. I ran out of space, guys. Hopefully you're a little neater than I am. But there's the pattern. 1 out of 5 something is something. And you're going to use a noun. It's not that hard to find the nouns. It's what you're talking about in the problem. Here, let me just show you the word problem real fast. Total number of fruit. Bananas to fruit. Total fruit. Now, what I can do to prevent this mistake or this confusion for next time is maybe just write total what? Maybe use the noun here. Total fruit. Will that make it easier for you later? Again, if this isn't necessary what I just did, don't do it. I'm just giving you ideas how to do this a little easier for next time, okay? The more you do this, the easier it gets, okay? I will say that. All right, so that's number 3. One more, and then we'll be done. Divide 28 cans of soda into 2 groups so that the ratio is 3 to 4. Oof. Now, I know the book asks you to use bar diagrams. If you understood the way I did it with bar diagrams and it makes sense for you, perfect. I'm going to show you another way that might work a little better for you, okay? So bear with me here. All right. Here we go with the famous dots, right? Groups of 7, 4 times. How do I know what to pick? Well, I have 28, and I know my times tables. I know I can break it up into one group of 28, one long line, 2 groups of 14, or 4 groups of 7, and so on. 4 groups of 7 looks a little better, right? So anyways, 28 cans of soda. And you know what soda is, like Pepsi, Coca-Cola, Sprite, 7-Up, whatever it is you guys drink. Do you even make 7-Up anymore? Yeah, I think I haven't had a soda in a while. At least not that anyways. I had a Coke, actually, yesterday. It's kind of nice. Haven't had one in a long time. All right. Sorry. All right, we're breaking up these cans of sodas into 2 groups. 2 groups. Group 1. Group 2. Right? That's what again, if you can imagine you with your friend, right? You have 28 sodas and you're splitting them up. Now, we could split them up evenly. It would be 14 and 14. Easy peasy, right? But that's not what we want. According to the problem, we want a ratio of... Let me look at it again. We want a ratio of 3 to 4. Okay? We want a ratio of 3 to 4. And I'm using that ratio symbol on purpose, the colon. So what's going to happen? Basically what I'm saying is, if you can imagine yourself doing this with your friend, I get 3, you get 4. You know, you're cool like that. You're not selfish. You give your friend more soda than yourself. All right. So 3 and 4, that's 7 sodas. There's my 3. Here's my... Oh, wait a minute. I just made groups of 6. Whoops. There. See? Mistakes happen, people. 1, 2, 3, 4, 5, 6. There. That works. Another 3. 1, 2, 3. Another 4. 1, 2, 3, 4. Right? And you know what? Let me use color since I have it here. 1, 2, 3. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4. One, two, three. You could almost... There's a certain rhythm to this if you do it right. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4. No, maybe not. Maybe it's just me imagining. 4. Another group of 3. 1, 2, 3. 1, 2, 3. Why don't I just do that, right? I should have just done the beginning. 1, 2, 3, 4. There. But that's okay. Okay, so you just made your 2 groups. 3 to 4. This person gets 3. this person gets 4. For every 3, they get 4. 3 to 4, 3 to 4, 3 to 4, 3 to 4. How many sodas do you have on this side? You have 4 groups of 3. 3, you can do times tables. 4 groups of 3, 4 times 3, which would be 12. Or 3 plus 3 plus 3 plus 3, which is 12. 4 plus 4 plus 4 plus 4. Or 4 times 4. Either way, it's the same answer. Okay. The ratio is 12 to 16, but what does that mean? 12 sodas in group 1. Excuse me. 16 sodas in group 2. And that, my friends, is the homework. I hope this made sense. Okay?